I think we can start. Yeah. Okay, so welcome everyone in person and online for IRI CCSR ENSO IOD and Climate Outlook briefing for April 2026. Thank you so much for joining. I'm Azhar, Associate Research Scientist in Center for Climate System Research. I am the presenter, and this presentation is also have work done by Jing, in particular, generating all these forecasts, and Dr. Andrew Robertson for the supervision, and Jeff for forecast post-processing and web updates. So thank you so much, all of you, for your contribution. So main headline for this month's briefing is that we have a Nino watch issued by CTC. We don't issue watches or those things. So we are more research and educational type of briefing. And what that watch is saying, and now next number is ours. So that Pacific conditions are increasingly favorable for the development of the El Nino. And those numbers for April, May, June 2026 are about 70%. So you can imagine that it's already, in terms of probability, 70% probability is assigned for the El Nino. So remaining 30% is left over for the ENSO neutral conditions. So we see how these things evolve during last 2 months. We are now meeting quarterly, not every month. So last time we met in January, and now in April, and hopefully next briefing will be in July. So let's see what happened during that time. So there's a brief outline of this briefing. We look at different observed conditions in the tropical Pacific and also in other areas of the globe. And then we look at the forecast of ENSO and IOD. And we also finally look at the sea surface temperature, precipitation, and temperature. And there is another thing, which is I'm not mentioning here, but we'll see in the last slide, a new product from Jing and the group that is interesting maybe for some people. So the first thing first, let's look at this map. This is March 2026 sea surface temperature departures. This is monthly values map across the globe. And what you are seeing over the equator on the far eastern side, this is orange and red colors popping up, expanding further into the west side. So these are all, since these are the departures, so these are anomalies, positive anomalies. Over the far eastern side, you may see that the values are close to more than +2 over the far eastern side of the equatorial Pacific. There is something in some leftover cooling in the central eastern Pacific, which is we can see in this March, and there's a lot of warming in the western side as well. So Indian Ocean basin-wide warming is there. Equatorial Atlantic is warming. North is little bit muted, and far northern we have these positive sea surface temperatures in there. We look at those indices that used to measure ENSO. So Nino 1+2 is the far eastern region. We just looked in the map. So its value is positive 1.6. Nino 3 is more than 1/4 degree warmer. Nino 3.4 is whitish and bluish. So we have about 0 degree for the month of March, or positive, we can say. And Nino 4 is about positive 0.38. So for the month of the March, we have these values. Next slide. is the tendency. So what happens during April and March? So April is last 20 days of the April, and March is the full month of March, and we minus those things, and then we can see that we have a lot of warming over the central eastern equatorial Pacific region. It's very significant as compared to what the warming we have during in the eastern and the far eastern. There is some warming more over there, but overall we see this pocket signal that shows the change in the condition from March to April. Now looking at the most recent 15 days values over the same global map. And the right side are the numbers that we have for last 15 days. So Nino 1 plus 2 is about 2 degrees, close to 2 degrees. Nino 3 positive 0.63, Nino 3.4 about half a degree warmer, and Nino 4 is close to 1 degree warmer than the long-term mean. And the pattern look like this one, as you can see on the screen. So we are heading towards the a rapid development of El Nino conditions over the equatorial Pacific. And the change of the condition that you have seen from the monthly March value and the most recent April values. So these are the surface conditions that we have seen and we are seeing in observation. I just put it here like making a comparison between the most recent El Nino event of 2023. So at that time, during this same period, 6 to 19 April 2023, those were the values recorded here on the screen. So you may, spot the difference between what we have now and what we have at that time. So more or less similar picture, I can say, but of course, we have some differences here and there in the eastern, particularly in the eastern, in the Western Pacific, I would say. So, what we are expecting, or what is going on that we don't see on the surface or otherwise within the subsurface. So, on the left side, we have 4 pentars from 22nd February to 8th of April. So as you can see, there was some slight cooling that was there in the first pentad on the top, go away, and then those values get strengthened. And in this 4th pentad that is ending and centered on 8th April, we have the maximum anomaly, which is about 6 degrees warmer than the mean. So you see the darker color, dark red color, about 6. The next one on the right side is the most recent one, which is centered on 13 April, and that is very nice and beautiful red shading covering all the equatorial Pacific from east to west. And at depth, its value is again close to 5 degrees or more than 5 degrees at some places. So that's the kind of situation that tells us that we don't see any blue shading in this one in the deep water. All is mostly warming conditions in there. So a lot of fuel available for the ongoing development of El Nino. This graph really is very interesting one. Actually, you can see that the last 1 year value of the heat anomalies that we have. Let me see it. Anyway, so it is between 180 degree to 100 west, which is hiding in this screen. I don't know how to move it away. So between date line to the 100 west is the mean that we make an index. So from mid-July to mid-December, we have these weak negative anomalies were there. You can see in this blue shading. And then afterwards, from mid-December, we start seeing the increasing positive anomalies. They took a pause at maximum between February and March, take a dip, and then they start increasing again. Quite a high number, how high it is. And I, again, like last slide, I want to compare it with the 2023. So you may see that the y-axis is different. So this y-axis is going hitting 2.5, while this one is 1.2. So I just try to make it, you see this is a small, but overall it's a try to join the zero axis. But you can see at that time, in 2023, we were having a value maximum at 0.9, while right now we are crossing 1.5 already. So a lot of buildup of the upper ocean heat content in this case, as compared to the most recent one, which is El Nino that we saw in 2023. So that's some signal there. And then in terms of the driving forces, one of them is lower level winds. So we may see that from these are the index values, trade wind index we have from last April to this 1st of March 2026. So you may see that these are getting the positive values. Most important one on the right side, where we see this red shading very dark, we have a very nice westerly wind burst or wind anomalies that we see here during during the last week of March and first week of April. And this is observed values. Then there is a GFS forecast that shows a mixed value. But again, we are at least seeing another weaker burst of the westerly wind. So if this materializes, that would give another, I would say, confidence or a kick towards the development of El Nino, further development of El Nino. Next slide is showing the Southern Oscillation Index, which is the pressure difference between Tahiti and Darwin. This one is for Tahiti and Darwin one. So March value was positive 8.9, while equatorial SOI value was already within ENSO neutral range. Don't worry. I mean, we see a very quick drop in this one. You may see here, from here to drop and reach to the red quadrant. So when it goes red quadrant, means that we have negative value of SOI. So which means if it's sustained, then a sustained negative value of SOI indicate El Nino conditions. I took it last yesterday. So its value is minus 7.3 already. It's dropped to minus 7.3. So SOI is in El Nino range right now. OLR. So between ocean and atmosphere, another very important variable that connects and tell us what's going on and how we can see the evolving conditions is outgoing long wave radiation. So if there is an El Nino, we see an increase of precipitation over the dateline and across the dateline over and around of that region. So we still see some weaker signal in there, but that's okay. It's maybe potentially we are seeing a start of the coupling between the ocean and the atmosphere. But overall, we see that over the dateline also this blue shading is turned into the yellow shading, which is another signal that things are getting reversed or in terms of ENSO development. So that was all observation, and now we have the forecast. And in the forecast, the first thing that we show is our famous IRI's ENSO forecast. It was issued already on 20th April. You have seen and already this plume. These include all dynamical and statistical models that we have. I think more than 20 plus models are there. Since we have two type of models, dynamical and stat models, so we have the two different averages, green and red. Red means dynamical average, green means stat average. And at the first season, you can see that The stat one a little bit lower as compared to the threshold value of 0.5, while dynamical are a bit higher as compared to the threshold. So already in the El Nino range. So I mean, you can play with these graphics. So I just took it that some of the models which are really very aggressive in terms of El Nino are these ones. Australian and NASA model is also one of those. COLA and KMA, uh, South Korean KMA, Korean Meteorological Carbon model. So these are all, you see these ones, 1, 2, 3, 4, 4 models showing very strong value of El Nino, 3.4 index in this case. This guy, usually we see when it is La Nina, we see the opposite direction, and now it is shooting on the other side, more than 3 degrees warmer as compared to the long-term mean. So that's
Is that their version 2 or their version 3?
I think this is version 2 or maybe version 3. Should be. So that's the plume. Then we have the probabilities as well associated with this plume. In this case, dynamical and stat are joining together. We get the average and then make a plume probabilities out of it. So from AMJ to DJF, El Nino is dominating. The first season, AMJ, 70% probability, and then it starts increasing, reaching up to 94, above 90 for several seasons during summer and early part of the fall, and then start slightly decreasing, but remain above 80% by the end of the year 2026. So main message here is El Nino is, as these red bars show, El Nino is dominating, increasing in probabilities during the forecast and during the rest of the 2026. Just to recall and remind or emphasize that these numbers shows that we are having values of minus 0.5 to 0.5 degrees Celsius. So one of the questions that usually when there is El Nino in particular happens, people ask that what will be the intensity of the forecast? So we used to have an ugly table somewhere. I tried to find it, but I couldn't. Sorry about that. So, but we have this one, a figure nicely prepared by CTC and ENSO diagnostic team. It's very nice, I would say. So it tells us that what is the probability or the chances of having an intense El Nino, or what we are having the expectation for that one. So just to inform you that this is not based on what we have seen in the previous one. This is the product by CTC, and it's used a relative Nino 3.4 index, or also known as RONI. You may see the word here, relative here. So anyway, so in this one, we have El Nino favored in MJJ as compared to AMJ, which is we are using traditional 3.4 index. But then afterward, we are also start seeing different category of the ENSO, or in other words, the intensity potentially. So what is the intensity that possible El Nino will hit or cross the warming more than positive 2 degrees is starting, we are starting to see in JAS with very small number, but then it start increasing, as you can see here. So in SON, OND, NDJ, and DJF, the number is start to increase one. So the chances that we may get a stronger one is about 30% by OND season. So quite high chances of getting a stronger Nino. Just you can imagine that if you compare it with traditional one, it may be higher even.
Yes.
Because this is relative 3.4 index,
Yes.
which is slightly muted warming as compared to the traditional one. I just want to share with you on this one because this is a new product just released, I think, this month from with the ENSO diagnostic discussion. figure 8 of the discussion page. We also do the IOD forecast, IOD Indian Ocean Dipole, which is the dipole index in the Indian Ocean. SST difference between the eastern and the western side of the Indian Ocean. So this project is based on NMME models, and on the left side we have the plume, all the models, and the thick red line shows the ensemble mean of all these or average of all of these models. What we can see here is individual model, we see there's some spread, one particular model behaving a little bit different, which is CFDL here. I don't know why it's to dip and then go up. Anyway, together, first 3 months, and this is monthly. So first 3 months and IOD neutral, and then the probability of positive IOD is increasing. On the right side, we have the probability numbers. So those numbers start to increase from 20% in May to 40%, 60%, 80%, and remain above 80% during September and October for this IOD forecast that we have issued. Those are the indices like IOD index, NINO 3.4 index, relative NINO 3.4 index that you have seen for the intensity plot. These are the spatial maps for the sea surface temperature forecast. For the first season, MJJ issued for April, first season. And then second, third, and fourth, main message we already seen in terms of index as well. We have a well-developed El Nino that we are seeing in these leaves. Plus, we are also seeing Indian Ocean Dipole. If you haven't seen the Indian Ocean Dipole, it looked like this one. We have warm anomalies on this side and some slightly nice and cute glow normal anomalies on the other side. And this remained there in the next season and this season. So that's the typical IOD pattern that looks like this one. Usually positive IOD follows El Nino, we know this thing, but not always. Looking at the precipitation, climate impact. So this is the first season, May, June, July. The forecast shows these probabilities. We have orange and brown dark shadings showing below normal, most likely. Green and blues are above normal, most likely thing. So what we can see here for May, June, July, this is late spring, early summertime. So what we are seeing is that we have a very typical El Nino signal in the maritime continent region. We have these below normal things there. And there is then with respect to the monsoon in South Asia, so we see this brown shading over the Indian region as well, which is maybe associated with below normal monsoon over there. Moving further, Madagascar. They said their rainy season is gone actually, but there maybe that late end of the rainy season is showing the below normal over there as well. Further into the American region, so Northeast America, South America region and the Central America region, Caribbean, it's all showing these below normal probabilities. On the south of or in the central western region of South America, we have a very quite strong positive probability, above normal probability basically there. Over North America region, usually we see this white and muted response, May, June, July. So not a fair signal, but overall some interesting stuff happening in the Alaska region, and where we see this above normal probabilities. One thing is over the northern, over this region, which is Middle East region, is showing this above normal in the first season, and I think in the other season as well. So maybe we can to the next.
ازاي بربنا في نقوكام او كبتريزا ماج
Is there a question or? Okay. So now a little bit different. I'm not showing the full global map. So rather, I'm focusing over the more over the regions. So first one I picked one is the region which is directly impacted by the El Nino case. So the first on the top from 1, 2, 3, 4, and 5 is the lead time, May, June, July, August, July, August, September, and last season here, August, September, October. All of these maritime continental region and over Australia region, we see these growing and strengthening probabilities of below normal from first season to second to third and the fourth one. So usually that's a typical situation happens during El Nino case. And moreover, we also see the Indian Ocean dipole. So when these two combine together and happens to come and they both occur simultaneously, there could be a superimposed impact of the drought, heat waves, wildfires over this region. So you can just recall in 2019 when there was a very strong positive IOD, there was a huge, very widespread wildfires and drought and heat waves happened in particular in Australian region. So that's a overall impact that we can expect, but I just keep the one headline on the top. Every El Nino is different, and so are their impacts. So also vary by region and intensity. But this is what we can expect from the forecast. So now next one is very important one, is the summer. Lately in the summer we have the monsoon, so which is the main rainy season in Asia and as well as in Africa. So lead 1, 2, 3, and 4 for Africa I'm showing on the top panels. And this is annoying. I don't know how to remove this one because this is very, I don't know, you are seeing online, that's, hopefully you are seeing all the things, not this black box that is hiding and those maps. So overall, I mean, Sahel region is quite muted in this forecast, and which is, as you can see from here, that there are mostly white areas. It shows climatological odd, and the spotted red, green, and the yellow shading in this plotting. And when we reach to the JAS season, which is the Northeast African rainy season, some have their regional name as well, is showing these very strong and growing probabilities of below normal. You can see that this grow all the way from one lead to the second and third. Fourth lead, which is hiding here, now imagine that what I'm saying you believe is ASO season, which is now getting the impact of the IOD. So when there is a positive IOD, things reverse. So we see, which is hiding here and behind this black box, is the very strong positive anomalies reaching up to 70 and 80%. So I mentioned here ASO over Northeast Africa. So positive IOD change the state from this flip to very wet side. Okay, so enough for the African side. Now we talk a little bit about Asian monsoon region. So at least in Pakistan and India, so we have these strong, on a seasonal time scale, these numbers are really strong. I mean, don't consider that 60% is a big probability. And this is what you are seeing right now is a lead 3 forecast, July, August, September. So typically central main monsoon region and in the western side, we are seeing this thing. And over the eastern side, like Burma and over Bangladesh, we are seeing this positive thing. We know that from correlation regression analysis, usually these are the things that could happen when there is an El Nino coming over Pacific. So wet in the east, dry on the west and central. Moving to the American regions. So top one is North America and Central America region. So Central Caribbean region, I'm showing the last two seasons, July, August, September, and August, September, October. So pretty consistent picture what we are seeing in this case from the Caribbean and the Central America and North America region. You can see here, please. You can see on the bottom as well. That's the same pattern that we are seeing on the top. One thing which is interesting and too far from the right now, but we can see from JAS to ASO. This is the also known as Southwest American monsoon region or Southwest American monsoon, whatever you can call it. So showing that we are having the increasing probability, usually start by end of June, early July. So July, August, September, October, quite, I would say quite strong. We usually don't see such a pattern. So it's a very rare pattern that I am seeing at least that such a strong values in a long lead in JAS and ASO season. So 45 and some about 50% probability is in there. South American and Central we already discussed on the top. We have this one, and there is some this blob of I would say the above normal that shift each passing lead towards the right side of me and or on the eastern side of the South American continent region. So that's all about precipitation. Moving to the temperature forecast. So this is the temperature forecast from May, June, July, usually very strong and red we see, but not always. So I mean, not always is maybe maybe I choose better word. So this is the May, June, July forecast. And I just want to bring the 2023 April issued May, June, July forecast. And you can see the change in the probabilities. If I take the difference, you may easily see that this year we have a much more stronger probability numbers as compared to what we issued 3 years back when the April 2023 or the 2023 El Nino was developing. Same time, you can see May, June, July 2023 issued April, May, June, July 2026 issued April 2026. So see the color shading, how strong we have right now. This is first season. And then I think I forget to change this slide to the other one. It's the same slide. Sorry about that. So basically my idea was to show you ASO season, which was even stronger and the muted from the ASO side. So sorry about that. But now we move to the last thing, which is not part of the outline, but now we are having this one as well. Thanks to Jing and some feedback from Andy and in particular from Gavin. So we are doing like some experimental global mean surface temperature forecast based on North American multimodal ensemble, or basically looking at the global mean surface temperatures in initialized model, you can say that. So what you are seeing, blue and red are not El Nino and La Nina. Don't be, get dodged by that one. Actually, it is the blue is showing the year 2024. Red is showing the year 2025 and green is showing the year 2026. So these are yearly anomalies of global surface temperature in initialized models. So, and this line that is coming from the top to bottom, then moving around, then taking another bottom, and then increasing is Nino 3.4 index that shows how the ENSO evolved. So I wrote some text here. You can read it. So but basically, so in 2024 January, we were having previously an El Nino, which were basically dying or decaying. So you say it was having this peak value, then it start going down, 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 and then turn into neutral. We have the global mean temperature look like this. Then La Nina came. We have global mean temperature like this. Then it turns into neutral for some time, then turn into La Nina again. And now we are again getting warming, which is right now here. And we are having the global mean temperature issued in this case. So the last bar in this case is for 2026, 4, which is April. So it is my mom. Sorry. This one, uh, and I just want to highlight to you that how this bar is standing higher or taller as compared to any other bar in this, at least from last 2.5 years. So, and while we were talking and just 15 minutes back, so I just thought that in the March, and you have already seen in the first slide that for the March, the Nino 3.4 was about 0. While in April, we are having about 0.5 degree already warmer. We saw in the weekly plot. So we are right now here, and the global mean temperature is, we are seeing the response from the models that is also increasing. So anyway, that's another new thing that we have. And I will be at the summary slide that tropical Pacific has been increasing and it has been experiencing ENSO neutral condition in March, but which is rapidly evolving into El Nino conditions. From April forecast, there are 70% probability for El Nino, and El Nino remain dominant. IOD first 2 months neutral, and then changing into positive IOD with rapidly increasing probabilities. We see the precipitation outlook is evolving with a developing El Nino condition. A lot of signal for El Nino development we already saw in maritime continent region and summer monsoonal regions of Africa and Asia in particular. We see a temperature mostly above normal, even quite stronger as compared to the most recent El Nino that we have in our mind, 2023. And GMST values from April 2026 start is also trending higher as compared to the last 2.5 year initialized values that we have in our record, basically. So we have a new logo. I thought this is a creation by NVR, so it's very nice to see that logo again and again. I want to highlight that we are having a new logo now. So this is all. If you have any question, comments, suggestion, or anything, please. Thank you for.
Thank you, Azar. I see there's a couple of questions in the chat from Robert Field. He's asking about the Ronnie index and is the CPC Ronnie ENSO intensity probabilities. Maybe you could show that slide. Are they from their model only, or are they multi-model? How do they come up with these probabilities?
These probabilities are not actually. It's a basically multi human generated ENSO forecast average, I would say. So there are some forecasters, each one do their forecast, and then those forecasts get averaged and go into the CPC or this plume. They don't have a plume in this probability graph as well as this intensity graph. So those forecasters have their own inputs from different models, which could be their own model if they have it, a secret one, or they mostly consider the NMME models or any other input that they have available at the time of issuance of these probability numbers or forecasts, I would say.
So they're asked to give their opinion, their prediction on the intensity as well.
Yes. So those numbers that are multi-model by the individual forecasters then, go into this intensity plot. I can say that, of course, that at the time when we do that ENSO diagnostic discussion, at that time, the input available is basically an MME model. So one of the biggest input in this is basically an MME model, I would say. Usually by that time, we have those models available. I hope that answers your question. Did you see positive ID impact on later part of the Indian monsoon? Yes, we see, Bohar. So actually, I don't know you are seeing that plot or not, but the ASO season. How? I don't know. So maybe just a second. I don't know. Are you seeing? So you see this one?
Yeah, but there is no Indian monsoon region. I can see that the OND season impact on the Eastern Africa, that is IOD, but Indian monsoon later part, like maybe August, September.
Oh, I think, yeah, I got your question. So
August,
I
September.
try to recall what the pattern looks. But for Indian monsoon, this is June, July, August, September. So imagine basically, Boha, that July, August, September is already like a peak of the monsoon. ASO is important because sometimes we see later impact,
Yeah. That's what I'm talking about.
I think those are muted as far as I can recall. In ASO, these probability numbers get muted. So maybe the positive IOD impact also starts to appear. What is your idea?
I don't know. We'll see after 3-4 months.
Will CCSR IRI continue to publish forecast on the website after April 30th? What changes should we expect after the closure of IRIDL? Sandy,
Yeah, I can answer that one. Yeah, good question, Laurel. I think they need to update their statement on the data library page. I believe it's the sunset date now has been pushed back to the end of June. But aside from that, at CCSR, we have a prototype data server that we're setting up that will serve the forecast data sets. So the ones from NMME, Subsea, and S2S that we've been serving, and it will also serve the forecast that we produce here. So we are planning for a continuation of these products.
See you, Jim.
Other questions? Do you have any questions? Can you put up the temperature map? You showed the current one versus 2023. With both of them.
May, June, July.
Yeah. So it's interesting to see. You see those blue spots that we have on our forecast, which look rather strange. We can see often the same spots also in 2023. So I think this almost certainly indicates a data problem, and people in those regions should not interpret those forecasts as being below normal. Another thing to mention is it's all baseline 1991 to 2020, so it's relative to that baseline, as is everything we show.
Yeah, I think we used to mention those things, but now we don't. Thanks for mentioning it.
Anyway, it's striking that this year we are seeing a lot more very high probabilities of above normal compared to what we normally see. So you're seeing here that you're seeing the global warming signal broadly, because it's with the baseline is 1991 to 2020, but then also the impact of SST variability, and particularly this El Nino, this case.
Yeah. So we don't know the forecast, so our understanding, but if we compare the 2023 and 2026, you are seeing the same season forecasted. Given there is the potential of developing El Nino, but you may see that how the impacts are different, because it's still red, but the probabilities in this case, look at, for example, Western United States. very strong probability. I forget to mention actually. I added the ESO season basically in my mind, but actually not here. So you see that's very strong, which means hot and dry and drought. So potential of having wildfire and drought condition is very likely. One of the reason and very big reason I was in last week in CPC forecasting webinar, that because this region, half of the western half of the United States is in snow drought. So they don't have a lot of snow already on the ground, which is to melt because of during this getting higher temperatures. So the soil is already drier, and we're seeing this kind of the signal. Compare it with the bottom one. Look, this is white, climatological odd, or very weak pinkish, baby pinkish, yellow shade, pinkish shading, which shows the probability 40 to 45%. And look at this one, this very, very strong numbers in there. So, and even in ASO season, it is getting quite stronger. So definitely, this is going forward is maybe a concern to keep an eye on the local conditions.
Can you show the SST map for that also? Because I was noticing off the coast of California that was very different between this year, very, very warm versus.
Yeah, observation was very warm.
The observation, yeah.
This one, this is March.
This one, yeah.
And this one is tendency. And this one is April.
Yes.
And it is very different as compared because I have the previous
yes,
one.
so there's a huge difference between 2023. So
yeah, this is you can see here. This one is blue, colder one, while this one is pretty warm.
And we can expect those to persist.
Yeah.
So that is probably factoring into this very warm forecast. There are high probabilities of above normal for that region, and as you say, fire risk.
Yes. So given the, I mean, you know, those conditions that could develop may bring those drought, of course. I mean, it's a dry region anyway, so it's a dry season, sorry, not region, dry season anyway, but overall then the high temperatures could also potentially increase the fire risk.
So in general, also the precipitation forecast, we're seeing some of the highest, the strongest tilts that we see in these forecasts toward below normal or above normal tercile. We don't usually see as much color on these maps.
Yeah, during this time.
So it's again during this time.
There is some light pink shading here. Anyway, I think any other last thoughts or comments or questions? No. So if not, then thank you so much for joining online, and we'll see you in July. Thank you.
Thanks,
Bye.
Amir. Thanks, Andy.
Bye, everyone.
Thank you, everybody.
Bye bye.